Hi, welcome to our presentation. We are the Gradient Descenders, and our project is sentiment and keyword-based Amazon review text generation. Hi, my name is Hyunjun. The objective of the current project was to develop a generative model for topic-driven text generation. More specifically, we studied the possibility of building a model that can generate human-like text while controlling the content of the output based on user-defined context such as keyword and sentiment. This project is important because the fact that one can generate plausible or human-like text about a user-defined topic with user-defined sentiment opens door to numerous applications. For example, if a malicious user of this generative model can generate thousands of negative product reviews on Amazon product to sabotage a product or generate positive product reviews to falsely promote their product that are in a plausible manner, this has a huge social implication. Through this project, we're exploring the feasibility of this application given the current state of technology. Our data set comes from Amazon review data from 2018, and we specifically use the clothes, shoes, and jewelry category. This category had over 11 million reviews, and it also contained review data, as in the rating, and the large sample size as well as the availability of the product ratings made the data set appropriate for the objective of this project. To give you an overview of the project, we use the fine-tuned GPT-2 model as our baseline model, and we fine-tuned a plug-and-play language model and conditional transfer language model for our more advanced model. Christina is up next, and Christina will start with presenting the Dash app of our final product to give you a better idea of our project, and we'll move on to exploratory data analysis.
Hi, I'm Christina. So right now, I would like to give you a better sense of how our model works. And I created this app to show the GPT keyword-based review generation model. Simply, we could just input the keywords and the rating that we want, and it would generate the reviews. Let's give it a try. So let's just try dress, and we want the rating 5. Just press submit, and later the results will be there. So here's the result. I love this dress. It fits perfect, and I'm 5'2", 130 pounds, and I'm a 34D. Wow, this is definitely a very positive review, and we can say our model works pretty well. Now let's go back to our exploratory data analysis. So I would like to start with the pre-processing. The first thing we did is to shrink the data size by only keeping the ratings and also the review text. We also create keywords using the Spatie, which is the package developed by MIT. We generated a feature called polarity to verify the sentiments of the text, which is the rating. Here is the distributions of both the sentiment polarity and also the distribution of review rating. We can see from both these two graphs, both the polarity and the ratings, they have the review sentiments towards the right, which means the reviews tend to be more positive, and these two sentiments kind of align. The left graph is the word clouds of reviews of ratings equals to 5, and the right is the word clouds of reviews of ratings equal to 1. So particularly from this word clouds, we can see for the review whose rating equals to 1, it mostly concerns with the size problem, since we see the most frequent words are fit, size, cheap, and tight. So next, Sion will introduce us how we fine-tune the GPT-2.
Thanks, Christina. This is Shayon. And before we go into the generation or fine-tuning GPT-2, I want to talk a bit about how we extracted the keywords from the reviews that we have, for which we use Spatie. And to parallelize it over the CPUs properly, we use Ray. Now, for the purpose of generating keywords, we look at the following parts of speeches, which are nouns and proper nouns, and for which we keep the raw forms of the text. And for adverbs, adjectives, and verbs, we lemmatize them to make the tenses equal over the different reviews. Following which, once the keyword is generated, we pack it into our input file as, so we have a start of text that is just indicate the beginning of our sentence. Then we have our course conditioning, the review rating, which is given by either 1 to 5, followed by the exact keywords which we want in our review, which serves as a fine conditioning. And finally, since GPT-2 is designed to make long form text, we add this extra token at the end to instruct the language model to truncate the generation once this particular end of text token is predicted. For the further fine-tuning, we use the method called gpt2.finetune, where we add the basic parameters are the model name, which we are fine-tuning, and from which checkpoint do we want to start our fine-tuning from. Once that is done, we could move on to generation, where the key parameters are the temperature, which controls the trade-off between the creativity and the sensibility of the text. And GPT-2 supports two different kind of sampling techniques. We can either use stop K or we could use stop P. Let's look at some results of the model. So for a rating of 1 with a keyword of belt, we see a very negative review about belt, which talks about very thin fabric or the material is super thin, etc. For a rating 3 with the same keyword, we expect a neutral one, as we see here, where the belt buckle was a nice addition, but unfortunately the buckle broke. But then if we have a rating of 5 with the keyword belt, we can say that like we see the review generated was the belt fits perfectly and the customer is very happy with this purchase. Having now that we have a baseline model, we tend to improve that with 2 more models. To begin with, we start discussing PPLM.
Thank you. Hi, this is Jason, and I'll be talking about PPLM, which is short for Plug-and-Play Language Model. This is a model developed by Uber, and it's specifically developed to be able to steer and control large, successful language models like GPT-2 to be able to complete more specific tasks. For example, discussing a particular topic or discussing a particular sentiment. While GPT-2 is fantastic at encoding information about speech patterns, grammar, and spelling, we're unable to force GPT-2 to perform specific tasks such as giving it a positive start of a sentence and forcing it to turn out a negative text. On the other hand, using PPLM, we have this flexibility in choosing our simple attribute models, which represent the objective of control that we want to impose and plug it into this large language model. The awesome thing about PPLM is that we don't need to train or fine-tune the underlying language model. This is useful because in many cases, these large language models available online are they take a lot of resource to train them, maybe money, maybe time, maybe even tons of data that isn't even available. So in this case, we can take other language models and plug in this layer on top to be able to do more specific tasks. Uber likes to use the metaphor that these huge language models are like a woolly mammoth that lumbers around aimlessly, and the plug-in attribute model acts like a tiny mouse that sits on top of the mammoth and steers the mammoth. So in our particular case, we're using a PPLM discriminator, which specifically focuses on sentiment representation. So what we do is we employ a single layer classifier attribute on top of that model, which takes the embedded representation from GPT-2 and forces it to lean more towards the correct sentiment. So let's take a look at some of our training information. As we can see, the training data did have some class imbalances, which I might talk about later. And also, here's a graph of some of the loss history as we were training it. So let's take a look at some results. First off, we start off with a start of sentence, this food, and we're able to generate a rating of 1. And we can see it's clearly negative. The food safety inspector warned of health hazards and a fatal accident. For rating equals 3, we see a much more neutral review. The food safety report, some sort of increase, talks about a House committee hearing on the report, relatively neutral. And finally, for the rating equals 5, we see a very positive review. The food is fantastic, it's delicious and nutritious too. Let's move forward. Even more in particular, that PPLM is able to do better than GPT-2 is be able to control their sentiment. For example, we can start with a very negative sentence that's just as tight, and then force it to give us a positive review text. So this just as tight, but it's flattering and cozy. It looks great. All right. On the other hand, we can also do it the other way around. We can give it a positive start of sentence. The shirt is nice, but instead force it to give us a negative review. The shirt is nice, but it doesn't have a collar or a small picture. I'm not sure what's on the back. It looks too expensive, etc. So we can see that PPLM has done very well at this. And next, we want to take a look at our final model.
I'm Alex, and I'll talk about CTRL, which is a domain and sentiment-based generation model. And this is a 1.6 billion parameter language model, which is great at allowing for controllable artificial text generation. And the model that we used comes from Salesforce. And the creators of this model, they've said that it's much less likely to generate random word sequences than previous models. And this is enabled through control codes, which are ways of specifying a domain for text generation. And these enable influence over the style, genre, entities, relationships between those entities, and dates. And these control codes might reflect politics or business, sports, and in our case, reviews. And if we look at the mathematical basis of CTRL, it's very similar to other conditional language models where we have the probability of a token given previous tokens, but in this case, we also have C, which is the control code. So we want to sample from this language model to generate tokens that make up this whole text. And CTLR penalizes samples that do not follow the context of the rest of the sequence. On the right here, we see two examples where there's a control code for Q&A, and we see who's first man on the moon, and the tokens that are most probable are Neil, Buzz, Apollo, so forth. So it allows for controlled token generation. And then if we look at some examples generated by the review control code, we can specify the control code and then the rating by giving the starting input as a score from 1 to 5. So if we look at ratings for 1, let's take this example here, the first one. This book is just another example of how to make money off of people who are gullible enough to believe in psychics, rating 1.0. Personally, I think this is very creative, but also on topic in the sense that it's a very negative review, but also is more complex than just this book is bad, too expensive, didn't like it. If we look at rating 5, we see I love these, I can take them anywhere and put them wherever I want, and they don't cost much, rating 4.0. And again, this is definitely positive, but one thing to note is that for the rating 5 prompts, we all get rating 4 outputs. And this might be due to an imbalanced lack of 5-pointer ratings in the training set, or just random variation. But overall, we see that CTRL is very good at giving us on-topic sequences of tokens.
Hi, this is June again. So what is our next step? Well, so far we have discussed the 3 different language generative models, and then we have found out that GPT-2 is remarkable in coding speech patterns, grammar, and spellings, and PPLM doesn't require a language model retraining, and it has stronger control over sentiment. And the CTRL can enforce the text to stay on topic. So our next step would be to combine the benefits of these 3 models and see what happens there. Thank you for listening.